Thank you very much, ladies and gentlemen, and welcome here today. I hope everybody pulled something small, even if it's one wee nugget out of today. It's always nice to get something out of a conference like this. As Paul says, I'm going to talk about, essentially, it's graphical and non-graphical data. It's about getting the data. There's not going to be a whole pile of AI in my presentation, but what we will focus on is the data and trying to have the correct data that we can use it and apply it. So the graphical and non-graphical data, thank you, is essentially, in layman's terms, it's as-built drawings. And just a bit of an introduction, just to try and frame this. I'm a mechanical engineer, so all of our stuff deals with mechanical services, electrical services, not so much architectural and structural, and that's kind of the focus of the presentation. Our company was set up in 2006, started producing O&Ms, as-built drawings, now fully fledged BIM services, specialising in M&E. We're also an Autodesk authorised training centre, of which I'm one of the certified instructors, and there's a few of us around here today. So in terms of as-built drawings, well, what are as-built drawings? And just to define them, well, essentially an as-built drawing, it is what it says it is. It's a drawing that's as the building is built. And it's the final set of drawings that reflects the completed installation. And when we present that in a 3D model, it gives us an accurate representation of how the building is built and how the construction works, but both on two sides of the same coin, graphically and non-graphically. So when we talk about graphically, we're talking about the geometric correctness of the building. Is the duct in the right place? Is the tray in the right place? Is everything laid out as it is on the site? But the other side of the same coin is the non-graphical, and equally as important, are we using the correct families? Are we using the correct families for the equipment, for the pipework, the fittings? If there's COBE requested in the project, is all of that information in the model? And does it sit to tell an accurate, and I suppose a trustworthy source of truth of the building? And the reason that this is all important, I suppose it documents the changes that have taken place from a design to a construction. And no matter how many times we say, well, we've built it as per the drawings, it's never really built that way. And for various reasons, and it might be to do with the type of materials, the type of building, the availability of certain trades or materials at a particular time. But buildings change and they evolve, and we need to document those changes as it goes. It reflects the true site conditions and it removes doubt. So again, you're about installing a wee bit of trust in your end user, in your client, that they can trust the drawings, that they're correct, and they can depend on them. It'll streamline future maintenance and expansion, and it'll simplify the handover process. And again, you've got something that you know is right, you know is validated, you're happy with it. And it'll enable easier facilities management down the line. And again, I suppose just from a legal and a contractual point of view, you've built what you've said you've built and you've documented what you've built. So that's my view why it's important. What I'm going to do is I'm going to take you through a couple of methods that we use to record as-built drawings. And we don't use any of these methods individually on their own. We'll use a minimum of 2, usually 3, sometimes 4 of these methods for various parts of the as-built. And starting, I suppose, at the top is the point cloud survey. The point cloud survey is essentially it's bringing the site back into that technician's desk. Everything has an X, Y, and Z in 3D space, and we have a full representation of what's on the site. It's highly accurate. Like I said, it's very visual, so you can bring that right back into your office. On the downside, you need specialist equipment for it, you need training to use the equipment, you need training to be able to interpret the data that comes out. But it gives you the record of the site. Now, when we come back to the site, there's a certain amount of intelligence in terms of how it's registered together, but we're back to the longhand then, updating the model to match the site. Other ways we can do it, we can use apps, and we can use the integration of a BIM app to record maybe the visual with the model. The beauty of this is we can link it to locations. It's very time friendly on it. Again, we have license issues and we need a little bit of training. Maybe a little bit difficult to cover it in the same level of detail that the point cloud can, but again, it's useful for particular applications. Going down then, more rudimentary ways of capturing it, the old-fashioned way, and we're getting back nearly to the way that we did it 10 and 20 years ago with photographs. I'm a firm fan, I suppose, of using photographs for the non-graphical information rather than the graphical information. what we used to find was if we were marking them by hand and trying to take photographs of the duct runs or the pipe runs, the bit that you want was always off the end of the photograph, and you always missed the bit that you needed. But in terms of recording pump plates, fan plates, AHUs, serial numbers, makes and models, this is, I suppose, it's second to none. The picture tells 1,000 words, and particularly where you have vertical sets and stuff, it's very graphical for the technician to visualize it. Again, it's very difficult to cover everything on it. And then back to the very basic way, the man with the pen and paper, or maybe the iPad these days, but traditional hand sketches. And again, for the non-graphical side of it, Oisin here is marking up, he's marking up circuitry on sockets and switches, device numbers on fire points and all of that, and stuff that's very, very difficult to capture in a point cloud survey. It's very onerous. So this is, I suppose the beauty of this is it's very quick, doesn't have to be a specialised person to do it. It can be done in phases as rooms are ready to hand over or as areas are ready to go. This can be done on it. Disadvantages, you're down to interpretation, and I can't read your writing, and why did you mark it this way? What did you mean by that symbol? But again, none of these methods are used in isolation. They're used a bit of this and a bit of that. I think in terms of the timing, we have to be very careful if we're going for the high level in the point cloud. A lot of what we want to capture is above a ceiling, and we need to be very careful on time. We want to leave it as late as possible till the installation is well advanced, but I don't want to leave it a day too late or an hour too late that the ceiling has gone in and I can't see it. So once we get the as-builts and they're done, we need to validate them because we need to have a level of trust, and the user has to have a level of belief that what he has is reliable. And there's a couple of ways that we can do it. We can do visual inspection. So once we have the as-built drawings, maybe spot checking an area in a building to see if it's right, or otherwise. The beauty of having the point cloud is we can go right through the building and we can pick the areas that we have doubts over. The difficulty if we don't have a point cloud is by the time the as-built drawings are done, typically the wall and ceiling closures have already been made, so we don't have that level of visibility on it. We can use a couple of tools in terms of automation. We can use clash detection. So for example, if I was taking a mechanical model and maybe you had an electrical model and Paul had a sprinkler model, we can clash them against each other. Now what that'll tell us is it should be clash free if the record drawings are right. It won't tell us what's accurate on site or not, but if it gives us a clash, it's indicative of a problem further down the line. And similarly, with rules-based automatic checking, we could say maybe if pipes are open-ended, it's not going to tell us if it's right or wrong on site, but it is indicative of a bigger problem. And then we get to, I suppose, probably the more intelligent-based methods of doing it, where we're looking at the point cloud comparison software, where we're converting a cloud to a mesh, we're running comparison between the two of them. I suppose what we've found from experience at the minute, it's great for walls, slabs, windows, doors, maybe a little bit less so on services at the minute, just due to the scale of them, to the sizes of the services. But hopefully that's something that's going to come down the line and make our life a little bit easier. And then we have the key: who's responsible for making sure this is done? So I don't know, would anybody have any views of who you think will be responsible for making sure the as-builts are right? The main contractor? Okay, so we'd say the main contractor. So main contractor, I mean, in essence, you're coordinating all the trades to hand it over and make sure it's right. We've got services contractors, or to use the BIM speak, we'll say the task teams. And I think they have a certain onus on their own integrity to make sure their own installation is right. We've the design team who will oversee to make sure that that the installation reflects the design intent. With the information manager, so maybe the BIM team, what power does the information manager have to make sure everything is right?
Too much, yes.
Too much or not? And I think this is a little bit subjective, and we all have our own opinions on it. The last one I have here is the owners or clients. So, in my mind, I think the client probably has the onus on them to say, well, this is what I want. And then the main contractor to make sure that that's delivered, and then the other pieces of the jigsaw fit in. But again, I think it's a little bit subjective on it, but everybody has a little bit of responsibility on it. And if we look at where it goes wrong, I think we're down to maybe responsibility. I'm thinking you're going to do it, you're thinking I'm going to do it, and it gets a wee bit lost. So, you know, assuming responsibility for the process is under the scope of the others. So I might think you're going to do a point cloud scan. You're thinking, well, why would I do a point cloud scan? You're doing the installation. You should be marking up your own drawings, and it gets lost. Or maybe I do a point cloud scan, and the electrician doesn't do a point cloud scan. Well, I've got information here that he should be using to make sure it's right. And why you know, so there's a little bit of maybe direction that can go wrong on the site. Changes to design not properly captured as they happen. Again, sometimes it can be subtle. You could argue it should be picked up in the as-builts. Sometimes it is, sometimes it isn't. Probably the easiest one to address is that the information is not captured before the closures are made on site. And I think that, again, it's a timing issue. It's something that can be organised, and it's an easy one to get. But once it's too late, it's too late. Then different approaches taken by different parties. So I might do it one way, and I might think, oh, well, I'm doing it this way, and I'm going to use my point cloud, or I'm going to use my sketches, or whatever I'm going to use. And my partner contractor on the other trade says, well, I can get away with doing this because nobody's going to pull me up on it. So, you know, it can lead then that my model is clashing with his model, even though they're both as-built models, supposedly. But I think the main reason why it might go wrong is that the process for creating the documentation is not explicitly described in the BIM execution plan. And we see a hell of a lot of BIM execution plans from one end of the week to the other. And they'll all demand as-built drawings, and they'll all demand asset information models. But very rarely is it explicitly set out how we're going to do it and what we're going to achieve in it. So we're on about AI today, and the conference is about AI, and we're thinking in the office, are we using AI? And we kind of thought we were. I don't think we are on reflection. I mean, we use the map to get to the site. We might use a retina scanner to get onto the site. I wouldn't describe either of them as AI as such. That they're intelligent and it's technology, but it's not artificial intelligence, or it's not a learning-based model. Maybe with some of the scan registration, we have assisted registration is bordering on that, and certainly the one at the end where we're coding, we might be doing our scripting or our add-ins to Revit to try and automate some of the more mundane tasks that we have in the office, might be bordering on it. But I think hand on heart, the only thing that's AI in this presentation is all of those 4 pictures came from ChatGPT. But you know, we're hoping that it's going to hopefully streamline some of the more mundane tasks that we have, and hopefully we'll be ready for it when it comes. But we're in a very traditional industry. I think it is slow to move, but it's good to see the adoption of technology anyways on it. So that's all from me. Hope you enjoyed the day, and thanks for coming.